This one is capitalize nest object keys. So capitalize the key of the object, and if the value is an array, iterate through the objects of the array and capitalize those two if they're objects. So objects are the only thing that have keys technically. I mean, not technically, because actually functions have keys and arrays have keys. People don't know that. You can say like function dot, I don't know. Well, in React, we do function dot component dot display name equals all the time, but I don't think people think about it that way. But anywho, yeah. What do you think about this one, Mike? Where would you even jump off the ladder?
Yeah. So this one, I'm going to introduce some new lines here just so I can read everything.
Please.
So this one is pretty scary, actually. It very obviously deals with recursion. It deals with nested object recursion. We even have to somehow figure out how to nest into those tuples of objects.
Mm-hmm.
But I think there's two really, really interesting aspects here, which is if we keep in mind what we're doing at each step, I think this one is actually maybe pretty approachable. The other aspect, I would say, I think this type challenge in particular really raises the idea of higher kind of types, because what we're doing, we're essentially doing two things. And if you'll allow me, we may get
Please.
into like the bread and butter of this. But one thing we're doing is we're mapping deeply over an object. And the other thing is we're doing capitalizing keys. So the ideal case would be we're taking in some sort of generic function. We're taking in capitalize basically as a parameter and running that across, which maybe that would be a lot. And I'm not sure about my ability to pull it off here, but I'm willing to try. But before we even get into that, let's keep it simple, right? So I'm just going to say in the beginning, we're going to say capitalize nest object keys is an identity function, right?
Yes.
Does nothing. Now I'm going to ask, does T extend? Is it an object? Is what I'm going to say.
Okay.
Is it an object? If so, I'm just going to return it. The second thing I'm going to ask is, let's get the formatting there. The second thing I'm going to ask is, is it an array? And if so, I'm going to return it. And if it's not, I'm going to return it. So we've done nothing. It's still an identity function. Now I'm going to introduce even more identity function stuff. So I'm going to say, let's visit each property, P in key of T, and let's just assign the value to T of P. So
still an identity.
Still an identity function. And I'm going to do the same for each array. So we've done a lot and we've done nothing still. So in this loop, we're kind of looping through each record of the object. And in this loop, we're looping through each record in the tuple.
Mm-hmm.
So what I'm going to say here is I'm going to actually call capitalize nest object keys for each entry in that tuple. It's still an identity function. And I'm going to do the same for each value in our object. So we've done so much, but we're still fundamentally in identity function.
Mm-hmm.
Finally, and I think this, for folks who know how object mapping and key transformations work, I think because we have this structure now, it's actually pretty clear what we need to do next, which is we're going to say so we're going to take P, and I'm going to introduce even more identity function. I'm just going to say as P, and then let's hover over this error. So we're saying, you're not going to like this, Dimitri.
Are you going to cast?
Yeah.
No.
So we
don't do it. You don't have to. Okay.
I'm gonna do
You're addicted.
You're
addicted. You need to go to Casters Anonymous.
Yes.
You need to.
All right, cast. So this is an identity function, right? We may be able to remove it. But what I want to, before we continue here, I just want to say the interesting approach we've taken is we've treated the whole thing as an identity function, and we've just added more structure to it and never actually changed what we're doing, which I think is a powerful approach for solving some of these problems. But now that we have this, we know, okay, we can perform arbitrary operations. I'm actually going to change this cast, and I know uppercase. I know we have like
Capitalize.
an upper.
Yeah.
Okay. Oh, capped. Is it a built-in actually?
Yes.
Okay, cool. I'm glad I didn't have to. I was going to do the extract the first letter.
No, you got it. Just
Okay,
and for anybody who thinks we're cheating, this was a prior challenge anyway. So
okay, and then I'm going to remove this one, and then I can capitalize always returns that. And then now I need to put a cast on this one. Maybe there's, if you have a better approach.
Yeah, I mean, you could do here, let me grab one. So
I
you could
stand
say
by cast.
So like there are options. Here's one option. Oops. Nope. Okay. I'm sorry. I copied the wrong thing. So here's one option.
That's the same thing.
It is the same thing. I mean, yeah, it is roughly the same thing. Yeah, I mean, chemically speaking, it's the same thing, but one of them has cast in it, one of them doesn't. What if I'm allergic to the term cast? You could also do that.
Oh, that's interesting. I didn't know that would work actually, but cool.
Yeah, I mean, potato, tomato.
Yes. All right, cat. So I think we have this. If you're what I would like to point out here is that if we had some sort of magic where we could make an F, right, and then do this. So we're saying we're running F, whatever operation F is. I think that would be a very powerful idea. Dimitri, are you down for me to try to show how we can
please.
Okay.
Do it. Now's the time.
All right. This is very, very I'm not prepared, but I'll try. This relates to like the internals of my HK2 toolbelt library, but I won't actually use that. I'll just sort of make a little minimal reproduction. So
while Mike's typing, I'll tell people. So one of the things I've done a poor job of that I hope to correct soon is like saying who the people are on these challenges. We have some like super cool people, and Mike's one of them. Mike has a library called HKT-Toolbelt. If you look on GitHub, you will find it. And HKT stands for higher kinded type. And well, Toolbelt is a utility library, so that's I presume where the toolbelt part comes from. And it provides a ton of different utilities that do these kinds of things. And what you're watching on the screen right now is Mike reinvent like his library from like, I don't know, off the top of your head, which just when I think you couldn't impress me more, Mike, you just pull these kinds of little tricks out of your hat.
Yeah, so I'll explain what I'm doing here. So what I'm doing, so I'm taking this, so this represents a type level function, right? And X is going to be the parameter, and F, this function F is going to be like what we're doing, like the process we're doing. So this dollar is going to be the like apply. It's going to be the invocation of this function. So it takes the function, it takes its input. This is very, very clever. And I'm not the one who came up with this. So we're going to take F, and what we're going to do is we're going to do an intersection. And what we're going to say is we're going to define X to be type of X here, like this. So we are sort of assigning X in this interface to be of type X. Then we're going to extract the function, and then we're going to get the return type of that function. And I believe for this simple case, that's all we need. And now what I'm going to do is I'm going to create a capitalize HKT. So I'm going to say interface capitalize HKT. I'm going to say extends HKT, and then I'm just going to define a little function that does what we want. So I'm going to say this is going to be just X is going to be this X, and then I'm going to say the return type is going to be capitalize type of X. And then we get a little this of X does not satisfy the constraint string issue, which you know me. There's only one solution. All right, so
Okay,
no type errors.
I'll let it
So
slide.
now I want to show you how this works now. So I'm going to say we're going to take capitalized HKT. I'm going to pass in foobar, and let's see. I very much hope this works.
It works.
Okay, it works. So now it's interesting because capitalized HKT is a generic without taking in a generic parameter. So what I can say now is f is going to extend HKT, and instead of invoking it like this, we're going to just use our little application operator. And
We can just pass P, right? We don't need to cast or any of that.
yeah, we don't need to cast anything like that. And then it's rightly complaining that we don't know that the return type of the HKT is going to be a string. So I'm just going to cast it as a string.
When all you have is a hammer.
Yes.
Okay.
And then it's saying we need to pass in F for what we.
Yes. Yeah, we got to pass it through now.
Okay, so now we really need to make these two types, right? So I'm going to say what we're doing here, right, is we're doing a deep object key map of some sort. So we're taking in an object, and we're taking in an object, and we're taking in some sort of like type level operation to perform. And then for this one, all we're doing is we're saying deep object key map T capitalize HKT. So
yeah,
putting some JSDoc there, I'll say the HKT to run to transform the keys of each object. And I'll say the object or array of objects to apply the transformation F towards. So now we have this thing, and we can create all sorts of like transformations. Now we can pass in the uppercase HKT and get a different one. We can pass in.
So like, I'm just gonna, I know everything else is wrong. I'm just gonna change this to uppercase, and then like, let's observe what the output is. So if I hover over A1, the output is that all of the keys are now uppercased in A1. And I know the name is wrong because it should be called uppercase HKT, but like, that's pretty, wow. So I have so many questions, but I want to leave a little cliffhanger. So we're very near the end of these challenges, and if anybody is super excited about this, I have great news for you. The next thing I'm going to do, the next little project, there are going to be 2 projects after this, after the challenges, and one of them is to do sort of exactly, like literally exactly what Mike and I just did, to go through and just like take a peek at some people's projects. I know lots of people have really cool side projects and things, like including people that have made really amazing big software that you use. Well, like many of those people, that's not the only thing they've ever done. They've done lots of cool things and nobody really knows about them. And they should, because they're really cool. And these are really cool ideas, really wild and interesting ideas. So I'm not going to ask you, I have a lot more questions, but I'm not going to ask you now. Mike and I are going to do a video about HKT Toolbelt, and we'll probably reenact some of this here to go through the basics of like, what are the big moving pieces of how all this works. I'm so impressed that you were able to just like snap your fingers and make this come to life on the screen in front of us without any dependencies. But yeah, get excited for that future. Any, I don't know. Mike, I'm realizing we didn't look at any other alternatives.
Oh, yes. I'm sure there are many.
This is super duper cool though, man. This is like a special place in my heart for this kind of stuff. Okay, I have to not. I have so many things I want to talk about that, but we will do it. Back to business. I got a job to do here. Just bad programmer. So this is interesting. This is it's asking is T an object array. Object is very similar. Some people did do what you did, record string unknown, or like record string never, or something like that is another. I think object works. There's something changed with object recently, and it works just as well now.
Oh yeah, V5.
Something. Don't ask me. I'm just here to talk. So if it is a read-only, so this isn't if it's an array, fine. If it's an object, do this. And so we see basically we have our like as remapping with the capitalization. This is what we saw before, and then we recurse with the value. But if not, then we're going to grab values of the array, and we're going to kind of recurse through that way. If we pass an object, then it will hit this case, and then we'll grab it. Otherwise, this is a kind of base case of recursion here. We just pass the value, and if there's any other kind of value, if both cases of these fail, then we'll just pass it as well. So, yeah. Any thoughts on that one? It's pretty, I mean...
Yeah, let's, looking into it, I'm a broken record on this sort of stuff. I notice where it is not tail call optimized. That's line 67. So because we're destructuring ourselves, that will cause that sort of like performance issue for very, very large objects. So I think that there's...
So what would you do instead?
Oh, yes. So we would probably introduce a accumulator of some sort. So I'm trying to, understand.
Oh, okay.
What we're doing here.
Well, let's look. Okay, let's hold that thought, because I have they're not. Yours is like way more different than the. I mean, I found a couple different ones, but let's hold that.
Sure.
And see if one of these is more to our liking. I think so. This is human detail. Each capitalized. So this is that inner chunk of what we saw up above. So roughly speaking is very similar. This starts with an object mapping. So just basics thing. A lot of people don't know. I mean, it's not basics, but you can use this syntax to map through arrays. And it's just a fun little quirk of how the syntax works, even though it looks like it's an object that it's only, or interface that's returning, but you can use it with arrays. So we're doing the capitalization there. We're checking if the values. So now we're we hit this colon, and now we're looking. All of this is looking at the values. So what I think is interesting about this is this will capitalize values, or this will capitalize the keys of. This part is ignored. That's highlighted when we're talking about arrays. So it's kind of interesting that they kind of sneak it in where you don't have to go through the question mark thing of, I don't know, the next level. But anywho, the capitalization happens here. We check if the thing inside, now we're looking at the values if it's an array. If it's not an array, then if it's an object, then we're going to just pass it directly. Otherwise, we have identity. So we see here we have our little identity guy is repeated a bunch of times. I like this one less. What do you think?
What is potentially confusing to me is line 91, because how I'm reading this is we're looping through every possible property in this object, right? And if it's a string, we're capitalizing it. That's good. If it's an array index, we're converting it to never, which I don't know what the behavior of that would be. My understanding is that it would remove elements of the array, but that doesn't seem.
I think the thing. Okay, so let's look at that. So let's just do this. All the tests are going to fail now, but that's okay. And let's do type x equals capitalize nest object keys. A, B, let's see here. So you see we got all those 0. So I think capitalize of 0. So p extends string, for whatever reason, it does not filter them out. You were expecting, I would expect 2. So if we just did this, okay, so if we just did this mapping structure here, we got rid of this, then we're just going to get, oh, interesting. We get all of the, what are we doing wrong? Oh, as. Okay, if we just did this, we just get A and B.
Yes.
But if we say as, the moment we say as, we start treating it like an object. And then do you see here how it capitalized length? It capitalized toString and toLocalString. These are pop. Yeah. These are not supposed to be capitalized. But it turns out it doesn't matter, because in the end, we're just looking at, it's a tuple and we're just looking at the values. So it like kind of sneaks by. I don't know if that was I would love to ask this person if they knew that this is how it works and what they did, but it just sort of like is like a little trick that happens to also pass. This is another one. Now we're getting into we're getting close to my favorite example. This is very near it.
I like this one.
Yeah, what do you like? Tell me, what do you like about it?
I like that it separates out the case of dealing with tuples versus objects.
Yep.
I am coming around to the interesting terse syntax on line 107, p and string, a way to, it's essentially doing that cast operation or intersection operation, because what we're doing, what the intersect operator does, and I think this is a very, very interesting point. The reason that this works, the intersection operator, you have to think about it in terms of Venn diagrams or set theory. By definition, what we're doing is we're cutting off all of the elements of P that are not a string. Therefore, capitalize knows that what it's getting is a string. So it's doing that process of like culling.
Right, but the question people ask that I'd like to ask you, what else could it be?
Oh yeah, so
what is in key of T that's not a string?
Yes. So what is P in this case that isn't a string? It could be a symbol. Objects can have symbols as keys. So TypeScript is rightly saying that if we have a symbol key, capitalize, can't take that in. So the other approach, right, is, which I think is pretty simple, is we just ask before we pass it in under capitalize. We just ask if it's a string, and otherwise we
filter it out.
Well, I would say actually we want to just perform the identity operation.
Oh, okay, leave it there.
Because yeah, it's not represented in the tests, but we could presumably have some sort of production input, which is an object with a bunch of normal string keys, but then there's like a symbol key. And I think we don't want to like remove it. We just want to only capitalize the string keys. So that's what I just sort of specified does. But I would agree that this is, in terms of readability, perhaps if you're familiar with the algebraic idea of intersection as a means of making the types the shape you want, the prior approach is maybe more understandable.
All right, let's see what you think about this last one then. Oops. So here we are. I like this one the most. And I think I like it the most is because, like, it's not really fundamentally different from the one we just looked at. In fact, I don't think it is at all different from the one we just looked at. Well, it does this part. It doesn't do the string and. This is how we changed it, exactly what you wrote. It just shows you, like, there's these two different cases, and the recursion happens with the object keys, but not with the tuples. Like, with tuples, we just want to, like, go find the thing, deeper down inside the tuple, but otherwise, like, I don't know, I just really like the simplicity of how this interface looks in the beginning. It makes it really clear that it's like it takes one path if it's a tuple, and it takes a different path if it's an object. The names reflect that, and the capitalization happens in the most obvious place. Like, I think the prior example was basically it was the same, but it did them inline, and I don't know, I kind of like this one.
I'm about to ruin your day.
Okay, please. Because it's not technical optimized. Is that what you're gonna say?
No, okay, actually, this is much more critical. So this isn't I would like to add a test case maybe, and you can agree whether or not that this should be represented as a potential case. So I'm going to go up above, and I'm going to add I'm going to add a B2 and an A2. And I'm going to modify these a little bit. I'm going to add a little C2. And you may know where I'm going with this. Okay, great. So, and what I'm going to change this input, and I'm going to say, I'm going to prepend something to bar, and this is going to be an array, and it's going to have quux number, right? So we have a little thing here where the first element of this array is itself an array that has an object inside it. You would consider this within scope, I believe. And
Yeah.
what we would expect here, of course, is this would be that array, and then quux would be capitalized. But, and then I'll make a comma here, but we see that it's not actually the case. So if we hover over, if we hover over A2,
yeah,
so it doesn't actually mention, it doesn't fully collapse the type representation. There's like a flattened type you can use to do this, but
yeah. What is it? Because do you remember a while ago you used to be able to like hold Alt or Shift or something, and then it would like expand them? How come that doesn't work anymore?
Yeah, that's yeah. I think it only works sometimes. And there may have been a compiler change.
I miss that feature a lot.
Yeah, there's a very helpful utility type that is actually in my library, but it's also like a very well-known type, which is, I call it infer or flatten or
merge
display sometimes, and it just forces the compiler to compute everything. But
okay. So what is the reason why this doesn't work? I'm going to delete, because we're getting near the end anyway. I'm going to delete all this stuff above. What is the reason? So let's look.
Yeah, I'll explain. So the key is line 47, based on my knowledge. We're assuming here that the first element of the tuple will be an object.
Oh, when really we need to pass it through. We need to pass it through this.
Exactly, and the test case passes. You fixed it.
Wow. Like a hawk in the night. I don't know if like an owl in the night, like a hawk. Anyway, like an eagle. You really spotted that from a mile away. Well, for me, for mere mortals, for non-mics, I just write more tests and hope to catch things like this. But yeah, wow. I can't believe that you saw that from so far away. It's such a subtle difference in my mind. Huh.
Yeah, that's what you have to do when you're trying to build a type library that, potentially thousands of people are using.
Yeah. Well, I don't know. I remain impressed. I look forward to more of these, and yeah, let's. I'm learning a lot. Thanks, Mike. Let's. Any other closing thoughts I should ask before we move on?
No, I think this is a very. I really like this problem because it gets to the level of complexity where we want to start thinking about principles of dry, actually. A lot of times in these type challenges, we just try to get at the solution, and it's kind of code golfy, and it's kind of like leak codey style, and we only want the result, right? But I think this is where it gets to, how can we write a result that is understandable? And I really like this solution because it does break it into multiple parts. And that's what I'm all about in terms of these more sophisticated type challenges, because the only way we can handle these more complex problems is by putting a lot of focus on how well can others understand our solution. Yeah, I think it's very important.
Awesome. Okay, that was a great send-off. On to the next one.
And the only reason I found this bug is because it was so readable.
Ooh, okay. That's a nice way that's a very diplomatic way to spin that.
It's true. Right. Yeah, it's a testament to this code, because the one, this is not related to types, but the one thing is that people can look at a very complicated sort of code and think, oh, it's very fancy, it's very high quality, and then they look at a simple code. Simple code is actually better because you can spot things like this. But yeah, that's more philosophy of software engineering.
You're not wrong. Yeah, I mean, case in point, you did spot it. So like, hey, there we go. Cool. All right. We'll have to know Links Yang 07 on Does that mean they were born in 2007? Wow, I'm getting old. Okay, well, we'll have to let them know. Or maybe it's 007. No, that would be 2 O's. Okay. Anyway, I tried. All right, on to the next one.